Welcome to Future Talk, the show that examines the global impact of technology, both for good and for bad. Our society is heavily dependent on technology, but maintaining that technology requires people who are very well educated, especially in math and science. But our methods of teaching math have hardly changed in the past several centuries, but that may be about to change. I have three guests to discuss some of the new approaches to teaching mathematics. Peter Fries is president and CEO of the Tech Museum of Innovation, which is the underwriter for this program, and he's also an experienced clockmaker. Keith Devlin is a mathematician and executive director of Stanford University's H-Star Institute, which studies the relationship between people and technology. He won the 2007 Carl Sagan Award for Science Outreach Activities and is known to NPR listeners as the Math Guy on Weekend Edition. He's written 28 books and is now working on a project to use video game technology to help middle school students learn mathematics. Salman is the founder of the Khan Academy, which is a one-man internet venture that aims to provide free, world-class education to anyone, anywhere in the world. His 1,400-plus videos on YouTube have garnered over 16 million views and have received glowing testimonials from all over the world. Khan Academy is now the most popular open education K-12 education resource on the internet, and it's recently been profiled on CNN, NPR, and the PBS NewsHour. Salman received the 2009 Microsoft Education Award at the Tech Museum in San Jose for using technology to benefit humanity. I'd like to welcome all of you to the program tonight. And Peter, let me start with you. What is the Tech Museum doing to advance new math education?
First of all, if you go to a museum, especially to a science museum like the Tech Museum is, then there is math everywhere. In every object you have math somehow. What is the difference to the normal school industry? When you come to a museum, you have to explore the space for yourself. You have to be very active, and it's up to you what you learn. But parallel to this, the Tech Museum offers some very interesting programs. One especially is where we bring teachers, kids, and parents together in one classroom. Because as we always know, kids go home and say, I have a problem to understand, and you have to have education from your parents. So sometimes parents don't even have learned themselves what's now going on at school. And therefore, building this triangle between teacher, kids, and parents is a very, very helpful thing. And that happens at the Tech Museum.
So is this sort of an experimental prototype where you're experimenting with different ways of learning the role of the parent, the role of the teacher, the role of the student himself?
Exactly. The Tech Museum would not be in Silicon Valley if we would not do these kind of experiments all the time. So we're looking for new ways of how to bring these difficult subjects closer to the people, that people really can make use of what they've learned in the museum and becoming a global citizen, a well-informed citizen about science, that problems like we have them right now down in Florida cannot happen or going to be treated in a much different way.
So does this approach, does it get outside the museum, so where, for example, school districts are watching your experiments and what you're doing and seeing how they could apply it to their own teaching?
Yeah, we are working together with teachers, we are working together with the kids, and we let them participate in building the museum. For instance, we have a program right now where kids are in front of teachers getting educated on a science subject for about 20 minutes, and then they have to repeat what they've learned in front of a camera. And these videos are really, really good. They show us what people can learn in 20 minutes and how they explain what they've learned to the audience. And those videos finally end up in the museum itself, in front of the science experiment. So the video basically, with the kid on the video, explains the science experiment. There are no labels anymore.
Well, I gather that there is a need to upgrade teaching because it hasn't really changed much lately and the needs have changed. So Keith, how long has it been since there has been a major upgrade to the way mathematics is taught?
Well, The three images that I brought along to show to the audience are from a book that was written in 1202. It's by Leonardo of Pisa. It was written in Latin. It's called Liber Abaci. It means the book of calculation.
Can we see those pictures? I think we have those images. Let's go ahead and show those pictures.
Okay, so this book appears in 1202. It was the first arithmetic book that ever appeared in Western Europe. It looks very little different from an arithmetic book today. It's that the language has changed. We don't write our books in Latin anymore. They've got a little bit thinner. That was about 600 pages. But essentially, arithmetic teaching hasn't changed in the West in 800 years.
Now, one might say, if a system has worked for 800 years, why does it need to change now?
Well, I think many people in our audience will say that it hasn't worked very well. We've been using it, we've used textbooks because for 800 years, that was the only way we could capture mathematical knowledge on any kind of device that we could distribute to a large number of people. It had to be text. But mathematics isn't about facts. Mathematics is a way of thinking about the world, problems in the world. It's something you do. Now, what's the best way to learn something you do? You do it. If you want to learn to play chess, you can learn the rules from a book, but you won't learn to play chess until you play the game. If you want to learn to play tennis, the book will tell you something, but you've got to go out and play tennis. You can't always learn by going out and doing the real thing. For example, if you want to learn how to fly an airplane, you learn in a simulator. If you want to learn how to be a brain surgeon, you will be trained in a simulator. The US Army uses simulators to train troops before they go to Iraq.
Now, how does this apply to mathematics?
So, mathematics learning is more like learning to be a soldier because there's a danger element that people will get scared. The best way to learn mathematics is either in a real-world environment where you're using that mathematics, and those are difficult to come across, especially with classes full of students, or you learn it in a simulator, and the modern word for a simulator is a video game. That's why I've spent the last 5 years looking at how you can use video games, massively multiplayer online games, to provide environments in which students can learn mathematics in a real environment.